Usually, when a computer executes a program, this program first came from a compilation pipeline, and what we execute in our computer is an instantiation of the generated binary. Exactly the same instructions and exactly the same behavior are executed in the computer clients. In our scale, we have several million binary copies distributed to the clients. This phenomenon is called software monoculture. Software monoculture has several benefits, such as maintenance, interoperability, and certification, since you only need to make the changes to your application one time and then distribute the binary. However, when you distribute the same binary alone or your computers, you're also distributing unknown security flaws. A potential attacker can analyze this code, discover these flaws, and then create an attack. Following the same idea, the attack can be delivered to million deployed instances exfiltrating data, for example. We call break once, break everywhere to this kind of attacks. How can we mitigate this threat? If we distribute a different binary yet with the same functionality, we can break potential attacks. For example, if we distribute different instructions making the same functionality of the original program, signature-based attacks could be ineffective. The main limitation of this technique is that you need to scale the number of different variables to real-world scale as fast as potential attacker can analyze and discover new flaws. Besides, you need to take care about creating new vulnerabilities. The program's generation needs to be safe and sound. We call this defense technique software diversification. The web context is probably the greatest example of what software monoculture is. Every time you load a page, this page contains the same resources gathered from a server. All of them are executed the same way with the same expected functionality. In 2017, a new language was added to this context, WebAssembly. WebAssembly is meant to be used as a fast language, fast enough to have native performance in the web. The software community is growing its adoption, and several languages and frameworks are being migrated to WebAssembly. C, C++, Go, or Rust code can be compiled to WebAssembly. We created a tool that replaces equivalent code in different parts of the original program during the compilation stage. Our approach is to tackle yet undiscovered potential vulnerabilities by providing several WebAssembly variants given a program source code. As a result, the generated programs are statically different and functionally equivalent. Going back to how the web works, every time that a client asks for a WebAssembly program, we serve a different variant. The variants that we serve are statically different, hardening the static analysis of the WebAssembly binaries. We also ensure to leave different fingerprints on the execution environment traces. This is the goal of our approach, to provide software diversity to the web through WebAssembly diversification.